The question is this: are we alone in the universe? Now, this seems like a perfectly reasonable question to ask. And if you think about it naively, just for a moment, it seems obvious that we shouldn't be alone. I mean, look around. We've got billions and billions of stars. Each one of those stars might have planets around it. We now know, just in recent years, that there are roughly 1 trillion planets, maybe more, just in our own galaxy, the Milky Way. And there are more galaxies than there are stars in our galaxy. So the numbers are absolutely staggering. Now, on this one little planet, Earth, we've got life. We've got intelligent life. We're sitting here, we're thinking about things, we're asking questions about the universe. So if it happened here, if intelligence arose here, on this one ordinary little planet around this ordinary little star, then it must have happened somewhere else too. The odds seem to be in our favor. You'd think there'd be life all over the place. So about 70 years ago, some clever people, including a fellow named Frank Drake, said, well, why don't we look for it? And this was a wonderful idea. Instead of sending rockets, which, by the way, is ridiculous because the distances are incomprehensibly vast. Instead of that, we could use radio telescopes. We could listen. We could build big antennas and listen to the cosmos and see if anybody out there is broadcasting anything. This makes perfect sense because, you see, if there's an intelligent civilization somewhere, they might be broadcasting radio signals. Or maybe they're trying to send us a message deliberately. Maybe they've got radio or television or radar, something like that. We emit all kinds of these signals into space accidentally. So if there are any aliens with similar technology to ours, maybe they're doing the same thing, and we could pick it up. So they started looking. They built instruments. They pointed telescopes at the sky, and they waited, and they listened, and they waited some more. And decades went by, 50, 60 years, more than half a century. And you know what they found? Nothing. Nothing at all. Now here's where it gets interesting. Because people started to get discouraged. They said, well, maybe there are no aliens. Maybe we are alone. And this idea, that we might be alone, became popular. It got a name. It's called the Fermi paradox. Fermi, who was a very clever physicist, he asked this question back in 1950. He said, well, if there are all these alien civilizations, where are they? Why haven't we heard from them? And so people took this question very seriously. But I want to stop you right here, because I think we're making a mistake in our thinking. This is a really important point. People are concluding that because we haven't found anything in 50 years, maybe the thing we're looking for doesn't exist. But that doesn't follow. That doesn't follow at all. Think about it this way. Suppose I'm looking for my car keys in my living room. I look around for an hour, and I don't find them. Does that mean my car keys don't exist? Of course not. It means either I haven't looked in the right place, or I haven't looked hard enough, or I haven't looked in the right way. But it certainly doesn't mean they don't exist. So let's apply this to the alien problem. We've been looking for 50 years or so. With what? With some telescopes, sure. But we're looking at a tiny fraction of the sky with fairly limited sensitivity. We're looking for signals on certain frequencies. And we're assuming that the aliens are broadcasting in ways that we can detect. But here's the thing. The search that was done in those early decades was actually very modest. They were using about 24 to 36 hours of telescope time per year. Can you imagine? A whole year, and they got maybe a day or two of looking. That's not very much. That's like looking in just the corner of your living room for an hour and saying, well, my keys aren't in this corner, so they must not exist. But then, a few years back, around 2015, something interesting happened. A fellow named Yuri Milner and Stephen Hawking, they got together and they said, you know what? Let's really search for this. Let's do it properly. They funded something called Breakthrough Listen. They put $100 million into it. And now, instead of 24 to 36 hours a year, they're observing for thousands of hours every year. They're using multiple telescopes. They're looking at things from different angles. They're searching in infrared. They're searching in radio waves. They're being much more systematic about it. So actually, we're not really stopping the search. We're accelerating it. But I think people got the impression that we stopped because the early results were disappointing and there wasn't much government funding for it. And so the narrative became, well, we looked and didn't find anything. So there must be nothing to find. But this is bad thinking. This is sloppy reasoning. And I want to talk about why it's so tempting to think this way, because that's interesting too. You see, humans are pattern-seeking creatures. We want explanations. When we search for something and don't find it, we want to explain why. The simplest explanation is often, well, it doesn't exist. But that's not always right. Sometimes it's just that we're not looking properly yet. Now, there's another thing that's interesting. Some people have proposed what's called the Great Filter. It's actually a clever idea, I think. The idea goes like this. We look out at the universe and we see 1 trillion planets. We should see civilizations everywhere. We should see Dyson spheres. These are giant structures built around stars. We should see evidence of mega engineering. We should see radio signals. We should see something. But we don't. So there must be something, some kind of filter that prevents civilizations from getting to a state where we could observe them. Now, where might this filter be? There are a few possibilities. One possibility is that the filter is in the past, and it was hard to get to intelligent life in the first place. Maybe the steps involved in going from simple chemistry to life, or from life to intelligent life, are incredibly improbable. So improbable that even with 1 trillion planets, only a few manage to do it. But here's something interesting. If the filter is in the past and we manage to get through it, then we're extraordinarily lucky. We might be the only intelligent civilization in the observable universe. And if that's true, it's actually quite hopeful for us, because it means no aliens are coming to invade us or anything like that. But there's another possibility. What if the filter is in the future? What if intelligent civilizations arise fairly easily, but then something happens to them? They destroy themselves, or they go extinct, or they don't broadcast in ways we can detect. That would be a bit more troubling, I think. Or, and here's the possibility I find most likely, what if we're just not looking in the right way yet? What if the filter doesn't exist at all, and there are civilizations out there, but we haven't figured out how to see them? Let me tell you about some of the subtleties here, because this is where things get really interesting. First of all, let's talk about the problem of communication. Suppose there is an intelligent civilization out there. Where would they be transmitting? On what frequency? You see, here on Earth, we broadcast on all kinds of frequencies. Radio, television, microwaves, infrared light, visible light. We're broadcasting all over the place. But an alien civilization might focus on just one frequency. Maybe they've discovered that microwaves are the best way to communicate across the galaxy. Maybe they're using something we haven't even thought of yet. So if they're broadcasting on frequency X and we're listening on frequency Y, we're not going to hear them. And then we might conclude they don't exist. But that would be wrong. Second, there's the question of where to look. The sky is huge. Our galaxy alone contains hundreds of billions of stars. Are we looking at the right stars? Some SETI projects focus on stars that are similar to our sun because we're biased. We think, well, if they're like us, they'll be orbiting a star like our star. And that's probably a reasonable assumption. But it's still an assumption. And it means we're not looking everywhere. Third, there's the question of how loud the signal is. If an alien civilization sends out a weak signal, and we're not listening with enough sensitivity, we'll miss it. And our telescopes do have sensitivity limits. We can detect signals up to a certain strength, but anything weaker, and we're blind to it. Fourth, and this is important, there's the question of time. Radio technology is very recent for us. We've only been broadcasting for about 100 years. Maybe intelligent civilizations are rare, and they're short-lived. Maybe they only broadcast for 100 years, and then they either destroy themselves or they stop broadcasting for some other reason. So even if there are millions of intelligent civilizations out there, only a tiny fraction might be broadcasting right now, at this moment in cosmic time, while we happen to be listening. Think about how unlikely that is. It's like trying to catch 2 radio broadcasts from opposite sides of a huge building at exactly the same moment, when each broadcast only happens for a brief moment in time. You have to be pointing the right direction at the right time, and the person on the other end has to be transmitting at the exact same moment. The odds are not in our favor. Now, there's another subtlety, and this is something that the people at the SETI Institute talk about. It's the question of what kind of signal we're looking for. We've been assuming that if there's intelligent life out there, they'll try to communicate with us. They'll send radio signals or laser signals or something like that. But maybe advanced civilizations don't broadcast their presence. Maybe they've learned that it's dangerous. Maybe they stay quiet. Maybe they're worried about being detected. Or maybe they're so far ahead of us technologically that they're communicating in ways we can't even imagine. Maybe they're using quantum entanglement or some other weird quantum phenomenon. Maybe they're manipulating the very fabric of space-time to send messages. I don't know, but we're assuming they're like us, communicating in ways we can understand. And that might be a big assumption. Now, here's something else that's interesting. Let's think about the question a different way. Instead of asking, why haven't we heard from aliens? Maybe we should ask, what do we know we have in common with aliens? Well, if aliens exist, if they're real creatures on real planets, they have to be made of atoms, just like us. They have to obey the laws of physics. They have to get energy from somewhere. They probably have to eat or absorb energy in some form. They can't be magical. They can't violate the laws of thermodynamics. They have to be consistent with what we know about the universe. So in some sense, they can't be completely alien. They have to have some things in common with us. They'll probably use light. Light is the fastest way to send information, and it's fundamental to physics. They'll probably understand mathematics, because mathematics is universal. It describes the structure of the universe. So if we wanted to communicate with them, we probably start with something mathematical. Prime numbers, the digits of pi, the fundamental constants of nature. These are things that any intelligent civilization would discover. But here's where it gets tricky. Even if we assume all these things, that they're made of atoms, that they use light, that they understand mathematics, we still don't know where to look, what frequency to use, how loud to shout, or whether anyone's even listening. And you know what? That's okay. That's fine. Because the search itself is valuable, even if we don't find anything. Let me explain what I mean. Science isn't just about finding things. It's about asking questions and trying to answer them systematically. And the search for extraterrestrial intelligence is a profound question. It's asking about our place in the universe. It's asking about the nature of life and consciousness. It's asking about the likelihood of intelligence arising. These are deep questions. So even if we search for 100 years and don't find anything, we'll have learned something. We'll have learned that intelligent life is rarer than we thought, or that it's harder to detect, or that it doesn't broadcast in ways we've searched for yet. All of that's useful information. But I want to come back to this idea that we've stopped looking, because I don't think that's entirely true. We've actually been accelerating our search in recent years. Breakthrough Listen is doing more observations than ever. There are laser SETI projects searching for optical signals. There are projects looking for techno-signatures, not just radio signals, but evidence of advanced technology. Dyson spheres, megastructures, anomalous heat signatures from stars. We're searching in more ways than ever before. The problem is, this doesn't make for good headlines. It doesn't make for exciting stories. So people have the impression that we gave up. But we didn't. We're still looking. We're actually looking much harder than before. Now, let's talk about something else that I think is important. There's a psychological component to this. Human beings are prone to something called the appeal to ignorance. If we don't have evidence for something, we conclude it doesn't exist. But that's not how science works. Absence of evidence is not evidence of absence. Let me give you an example. Suppose you've never been to Australia. You haven't seen a kangaroo. Does that mean kangaroos don't exist? Of course not. It just means you haven't been to Australia yet. The same logic applies to aliens. We haven't found them yet. That doesn't mean they don't exist. It means we haven't found them yet. But there's something else going on too. When people concluded that maybe we're alone in the universe, that's actually comforting to some people. It makes us special. It makes humanity unique. It makes us the only intelligent civilization in the entire cosmos. That's a very appealing idea, psychologically. It's flattering. So people are somewhat motivated to believe it, even without strong evidence. On the flip side, there are people who are terrified of the idea of finding intelligent aliens. They worry about invasion. They worry about contamination. They worry about all kinds of bad things. So they too are motivated to believe that we're alone, or that aliens are so far away they can never reach us. So we have these psychological biases pushing us in both directions. And they influence how people interpret the null results of SETI searches. But let me be clear about something. The question, are we alone, is not a matter of opinion. It's an empirical question. It's a question about the universe. And the only way to answer it is through observation and experiment. And that means we have to keep searching because we don't know the answer yet. Now, here's something I find rather beautiful about this whole situation. The question itself, the fact that we're asking it, the fact that we're searching for it, that says something important about who we are as a species. It says that we're curious. We want to know about our place in the universe. We're not satisfied with just living our lives. and not asking these big questions. We want to understand. And that curiosity, that drive to understand, that's what makes science possible. That's what makes civilization possible. So even if we never find extraterrestrial life, the search itself has value. But I'll tell you something else. I think we probably will find evidence of life beyond Earth eventually. Maybe not intelligent life. Maybe just simple life. Maybe just microbial life on some distant moon or in the oceans of some exoplanet. But I think we'll find something. And here's why. The universe has all the ingredients for life. We know that. We found organic molecules in meteorites. We found organic molecules in the interstellar medium. We found water. We found carbon. We found nitrogen, all the building blocks of life. The universe is full of these building blocks. So the question isn't really, is life possible out there? The question is, how common is it? And I think the answer is probably pretty common. Not necessarily intelligent life. That might be rarer. But simple life? I'd be surprised if that wasn't all over the place. So I think in the next few decades, as we develop better telescopes and better techniques for analyzing exoplanet atmospheres, we might find biosignatures. We might find evidence that some distant world has life on it. That would be remarkable. That would be profound. That would answer one of the deepest questions we can ask. But it might take a while. We have to be patient. And we have to keep searching even when the results are disappointing. Because that's how science works. You ask a question, you design an experiment, you look for the answer. And sometimes it takes a long time. Now, let me come back to the title of this talk. Why do we stop looking for aliens? And I want to propose an answer that's a bit different from what I said before. I think what's really happening is this. We've had unrealistic expectations. We expected to find a signal pretty quickly. We expected it to be easy. We set up some telescopes in the 1960s and 70s, and we looked for a few decades. And when we didn't find anything, we got discouraged. We thought, well, maybe they don't exist. But that's like drilling for oil in one location, not finding anything after a few years, and then concluding that oil doesn't exist anywhere on Earth. It's a flawed inference. The reason we seem to have stopped looking, or at least the reason people think we've stopped, is not that we actually stopped. It's that the early programs weren't well funded and didn't generate headlines when they found nothing. So the public impression was that we gave up. But the scientific search has actually continued, and in recent years, it's gotten much more intensive. So I think the real answer to why do we stop looking for aliens is that we never really stopped. We just hit a rough patch where we didn't have enough funding and enough public interest. But that's changing. The recent initiatives like Breakthrough Listen have attracted major funding and major scientific talent. So we're actually looking harder now than we ever have before. But beyond the practical side of things, there's a deeper point I want to make. And it's about how we should think about unknown things. In science, we encounter unknowns all the time. We don't know the answer to many questions. And when we don't know something, we have several options. We can say, well, I don't know, so I'm going to try to find out. Or we can say, I don't know, so I'm going to assume it doesn't exist. The second option is easier, but it's also wrong. The right approach is to say, I don't know, so I'm going to design a careful experiment to find out. And then I'm going to look and see what the answer is. And if I don't find what I'm looking for, I'm going to try a different approach. That's the scientific method. And that's what we should do with the question of extraterrestrial life. We should keep asking it. We should keep searching. We should keep refining our methods. And eventually, we'll get an answer. Maybe the answer is, yes, there's life out there. Or maybe the answer is, no, apparently we're alone. But we won't know until we've really tried. So I don't think the real issue is that we've stopped looking for aliens. The real issue is that we're impatient. We want answers fast. We want them to be easy. And when they don't come quickly, we get discouraged and we assume the worst. But life, at least life as we understand it, evolved over billions of years. The universe is 13.8 billion years old. We've only been searching for intelligent alien life for about 70 years. That's the blink of an eye in cosmic timescales. So maybe we just need to be patient. Maybe we need to search harder and smarter than before. And maybe eventually we'll get our answer. In the meantime, the search itself teaches us things. It teaches us about radio astronomy, about how to analyze data, about how to think about planets and environments and the conditions for life. It teaches us about ourselves, and that's valuable in itself. So my answer to the question, why do we stop looking for aliens, is this: we don't. Not really. We get frustrated sometimes because the search is difficult and the results are not forthcoming. But as long as there are curious humans on this planet, we'll keep looking. Because that's who we are. We're the creatures who ask questions about the universe. We're the creatures who search for understanding. And that, I think, is something to be proud of.